Good day. Today we are going to solve an ordinary differential equation. First, we are going to solve it manually. Then we are going to program it in Jupyter's Notebook. So this problem is going to use the Euler's method formula. Euler's method formula is given by y sub n is equals to y sub n minus 1 plus h or height times function of x sub n minus 1, y sub n minus 1. So the problem is to use Euler's method with step size 0.3 to compute the actual y value at x 0.9 of the solution of the initial value problem y prime is equals to x squared, y0 is equals to 1. Taking function of x is equals to y prime is equals to x squared. So we have here a line in which the spans of every points are of length 0.3. So for the first value of n, which is 1, we are just going to put the Euler's method here, and then we are going to substitute the corresponding values. So y sub n, y sub 1 is equals to y sub 0 plus height times the function x sub 0, y sub 0. So the value of y sub 0 is indicated here. It is 1 plus 0.3 because the length of every point is 0.3, and x sub 0 is this 0, and y sub 0 will be here, and it is also 0. So y sub 1 is equals to 1. We just put the value of y sub 1 here, and the value of x sub 1 is equal to 0.3. For the second value of n, which is 2, we just also put the Euler's method formula here and then substitute. Y sub 2 is equals to 1 because y sub 1 is 1 plus 0.3. The 0.3 is constant. It will always be the same. X sub 1 is 0.3. It's here. And we assume that y sub 1 is equal to 0.3. So y sub 2 is equals to 1 plus 0.027. Hence, it is equal to 1.027. So y sub 2 is equals to 1.027, and x sub 2 is equal to 0.6. So for the third value of n, which is 3, we just substitute also, and y sub 3 is equals to 1.027 as indicated by this, plus 0.3 times 0.6, and we also assume that the value of y sub 2 is 0.6. So y sub 3 is equal to 1.027 plus 0.108 is equals to 1.135. So we just put the value here, and the value of x sub 3 is 0.9. So we already answered what is asked from us. Compute the actual y value at x is 0.9. The actual y value is 1.135. Now we are going to program it in Jupyter's Notebook. So first, we are going to import matplotlib. Then we are going to define the function. and return x times x. If you can observe, the inside values of every function are the same. Here, both the values of x and y are 0. The values of x and y here are both 0.3, and here both 0.6. So we just put x times x so that x will be squared. What is the value of y will just be squared, and then we will get the value of the inside values of function. So we put y plus equals height times function of x and y. We write it this way because what will be the value of height times the function will also be added to the value of y. The same thing goes here. The value of h will be added to the value of x. So this is the end of the program. So let us run the code. So when the value of n is 1, the value of x is 0.3 and the value of y is 1. When the value of n is 2, the value of x is 0.6 and the value of y is 1.027. When the value of n is 3, the value of x sub 3 is 0.89999. When you round it off, it will be 0.9, and the value of y is 1.135. So this is the plot showing the results. When the value of x is 0.3, the value of y is 1. When the value of x is 0.6, the value of y is 1.027. And when the value of x is 0.9, the value of y is 1.135. That's it.